Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
Last podcast we did, there was mention of snow. So we haven't had snow here for a while, and we have many things have happened to us since then. I went to PyCon. I gave a little presentation on to the typing summit, and I did everything about types because I'm working on a book which you can find right now. It's called thinkingintypes.com. So if you go to thinkingintypes.com, it'll take you. It's in process. It's Python types.
Nice.
And which it turns out are way better than TypeScript types.
You've also been learning TypeScript.
Oh yes, we've been learning TypeScript because we're no promises, but we're trying to translate thinking or effect-oriented programming into TypeScript. The effect library in TypeScript.
Yeah.
And so we're having to learn all about TypeScript.
Yeah.
Which is feels like a step back.
I'm not convinced on structural types, but
no, I don't think. I mean, the way I'm describing it is structural typing is like if you're doing small things, it's like Python before types. If you're doing small things, it's probably fine because you can be sloppy. But if you start, it doesn't scale basically. Yeah. So,
I think with enough rigor, you can do it.
Mm-hmm.
And with the effect library, it adds in a bunch of things that should be standard library.
Yeah.
Types that should be standard library types, and so that's like the way to do TypeScript at scale is with effect.
Yeah.
But so it's been fun to dive into that.
Yeah, no, I mean, I've encountered. It's just I feel like at some point that maybe I had gotten out of the language compromise thing, where it's like, oh, but we wanted, C++. We wanted it to be easy for C programmers, so we, made it so that C would compile, and then we have a bunch of compromises because of that. And TypeScript's the same thing.
Yeah.
It's like, we don't want to scare away the JavaScript
We're going to have to
too much.
ask our guest about his experience with TypeScript.
That's right.
Because he spent a lot of time in that world.
So he can probably give us some insights.
Segue,
so the other thing is the Summer Tech Forum, which is September 8th through 14th, did I say? I think. Yeah, that sounds more or less.
Your retreat is different than
no, that's this weekend.
Oh, okay.
No, that's
so you've got a developer retreat happening this weekend.
This weekend, that was just
developers
kind of fell together.
Retreating to Crested Butte to write code or do whatever they want to do.
Exactly.
Watch fireworks at my house.
That's right. All of those things. No, the Summer Tech Forum is September 8th through 13th. Anyway, it's up there. summertechforum.com, and you can register now, and we know we have some people coming, so we have enough to make an interesting group. So that's what we're going to do, and then like mostly the reason that we haven't had podcasts is that you've been traveling and
doing AI things
and now installing sprinkler systems.
Yeah, I'm working on installing a sprinkler system.
That's your new second career.
Yeah.
Sprinkler system.
If only I could have AI do that for me.
If it doesn't move dirt yet.
Yes. Yeah. I guess I'm setting up myself for when AI replaces me. I'm going to be able to install sprinkler systems, guide rafts down rivers.
Mm-hmm. Oh, that's right. You took a raft guiding course.
Yeah, that happened since our last episode too.
Oh my gosh.
I was 2 weeks on the river, and it was great, and been taking my family out on the river like every weekend since
really?
Then. Oh. Yeah. So it's been awesome.
Okay.
But anyways, that's why we haven't and then just the chaos of AI stuff.
Right.
Somebody described it as like the AI meteor hit the tech world, and things have just been insane since then. So,
okay. So
that's why we had our guest. That's why we have our guest Rod Johnson on, is because I've been diving into his new stuff, Embabel. Did I get it right that time?
Yeah,
Rod?
You got it right. Hi guys, good to talk to you.
Thanks, Rod, for joining us again.
Wait, Babel is a language or a
Embabel is a agent framework, a way to build AI agents.
Okay.
I mean, I should let Rod describe it, but I've been diving in, and awesome.
Really?
I'm loving it, and I think it's the future.
And so, do you have a team developing this, or is it just you? Or
Well, it's kind of open source, so the whole world can come and help, but obviously you do need a core team. So most of the code to this point has been written by myself. I've got a developer who's pretty much full-time in New York, Alex Heifetz. It's a very good Java Spring developer that I've known for many years. And more recently, Arian Pootsma of the he worked on Spring for 19 years. So Arian has joined the engineering team. And we've also had some fabulous community contributions, literally from around the world. And that has actually happened, that happened within a week of the project being opened up.
And this is only like a couple months ago. You just open sourced it. What was it? Back in May, April?
It was whatever day my talk at Kotlin Conf was, 22nd of May, I think, something like that. So yeah, it was
2 months ago, and it's already taken off.
So what is it that we're talking about?
Oh, and you got to tell Bruce the origin of the name, because I think he'll
yeah, I know nothing about this thing.
Yes. Okay, so let's start with the name. So the name actually came from a road trip with my son. Probably 18 months ago, we were riffing on names, and I think it was largely his idea. So it's indirectly inspired by the Tower of Babel story, but more immediately via Douglas Adams in Hitchhiker's Guide. If you recall, the Babel fish is this little thing that you put in your ear, and once you've done that, it's kind of can be bad. You can understand Vogon poetry, which you wouldn't understand if you hadn't got the fish in your ear. So it's about
but it's
this
not
idea.
just Vogons. It's all languages.
Everything. All languages.
Right.
Yeah, so it's basically the general thought of making, natural language, empowering natural language is the kind of conceptual frame I'd have for it. And I kind of like the fact that it sounds a bit like enable. So that's the name.
Yeah. Mm-hmm. So you spent, let's hop back to the TypeScript thing since we mentioned that. So you had a startup before the Embabel agent stuff, and you were doing TypeScript. And because we mentioned it, what's your years and years in the world of TypeScript? What's your take on that?
I have to say I disagree. I would far prefer to write something complex in TypeScript to Python. And I mean, I am in strong agreement about the importance of Python types, and I think that that's revolutionized Python. And anything I do in Python is as strongly typed as it can be. But I actually think the compromise in TypeScript has been executed really quite well. So you get the JavaScript, ecosystem, the ability to introduce it in a lot of places. You obviously do have some original sins of certain things in JavaScript that are just insane. But, having said that, I think what the language itself does is pretty cool. There are things I actually miss about the type system. I would love to have union types. There's the way in which, for example, routing is handled in Embabel. If we had union types in Kotlin and Java, that would be just beautiful. It's just slightly more clunky because that concept does not exist. The structural typing thing, to be honest, I don't tend to think about that much. The way I have personally used the type system in TypeScript, I would describe it as significantly better than Java's type system. Because you've got type algebra, you've got partials, you can make things, you've got union types. There's a bunch you've got pick, where you've got a subset of, particularly the ability to empower the caller through union types, I think is very interesting.
Yeah. Reduces the number of patterns that you have to cobble together to
and I can see I can see your point. If you're coming from Java, yes, it does seem better than Java, but Python's type system turns it into a nominative system, and it's patterned after, as near as I can tell, it's most common with Scala than anything that I've seen. And so it has all of that power. And so I'm going from that to TypeScript. You're going from Java to TypeScript. That's like, okay, sure, definitely. I would agree that I would prefer TypeScript over Java.
Yeah.
So, but also you've been using Kotlin, you said.
Yes.
Let's dive in there on Embabel and the, well, first of all, what it is, and then the Kotlin
and it's
side
not
of it.
Babel, it's Embabel, is that right?
Embabel, Embabel.
A-M or E-M?
E for echo.
Okay.
Embabel.
So it's Embabel.
Yeah. Okay. So what it is fundamentally the biggest problem I think facing the enterprise is how to leverage Gen AI. Right? Every enterprise on the planet has a board level initiative towards making greater use of Gen AI. Whether or not that's always sensible is a question, but it's happening. And clearly this is a technology that has enormous power. But it's a technology where the promise is still a long way ahead of reality. So, the promise when you go on to Twitter or LinkedIn or any source of feeds, you get all this stuff, some of which is generated about how this changes everything. And so far, I think there's some things that have completely been changed, and there's other things where the usage of the technology has just hit a wall. So, for example, personal assistant use case, even writing code, assistance in writing code, absolutely awesome. It still utterly baffles me that there exist developers who try to dismiss the potential of AI code assistance. I mean, I guess these people are Luddites, and they're going to experience the same fate. But that is clearly very good, as is the personal assistant use case of how we all talk to Claude or ChatGPT or whatever. But the way I tend to think about it is both of those things are still really fundamentally very much human in the loop. So let's suppose I ask Claude a question about something, have a conversation with it. Usually it's good. Sometimes it's just way off base, and I'm like, okay, that's a bit weird. So the way I think about it is let's imagine, to make the math easier, that 90% of the time it's super helpful. And 10% of the time it's somewhere between not very helpful and actually really misleading and wrong. Literally, I was talking to it this morning and it just hallucinated a method that does not exist in an API. So if it's 90% of the time it's really useful, 10% of the time it's not useful at all, or even worse, that we've described a system that has 1/9 of reliability. Try building any business application on something with 1/9. Fundamentally, if you're doing any serious business process and you've got 1/9, it does not work, right? I mean, this is binary. It does not work. It's not that it works 90% of the time. It does not work.
As evidenced by the Anthropic project, where they used an agent built on Claude to run the business of their vending machine. Did you see this article?
Yeah, I saw that.
And it just came out in the last few days, but it failed miserably to make a profit at running just a little vending machine. And at one point the vending machine said that it said, if you want your items from the vending machine delivered, come find me, I'll be wearing a suit and tie. It just totally hallucinated it, what it was. And but I think at the end of the day, the important thing is that it failed to actually run a viable business that was the vending machine in the Anthropic office. And so I think, to your point, 1/9 of reliability for the enterprise likely is not enough.
Right. So how do you get beyond that, and how do you build business systems that really work? So one approach, of course, is throw tools at your LLM. So the pure MCP direction. There are definitely some folks who believe in this. I wonder if Anthropic actually maybe genuinely believe in this. I don't think it's sufficient. The reason being that you are granting too much autonomy to the model. You're trusting it to call the correct tools in the correct order. And also you tend to be locked in to really, really powerful God models. And there are some problems with that. One is that model portability is going to be an issue, and there may be reasons you want to use a different provider. Secondly, you're never going to be able to use local models. And in fact, there are many problems where local models have a lot of benefits. Thirdly, you're environmentally, potentially disastrous because you're always using things that are incredibly powerful, where maybe some things could be done consuming less electricity and water. So, the first way you get past hallucination is RAG and tool calling, and obviously that's really important. But I believe that a level of orchestration is incredibly important at a higher level. So the way I view this is prompting an individual LLM and giving it tools is the atomic unit. But you need something that composes those atomic units into a reliable system. And that enables you to do a variety of interesting things. It enables you to mix good old-fashioned code for certain things that you can do in code that are infinitely cheaper and also more deterministic. You can mix code with your prompted interactions. You can put in checkpoints, guardrails. You can persist where you are in the flow, right? There's a whole bunch of things that you get as advantages by this kind of refactoring. So this has taken us to what is essentially the world of agent frameworks. So far in Java, we've principally had lower level frameworks like Spring AI and LangChain for J. What they enable you to do is prompt an LLM and do that portably as you'd expect with Spring. Doesn't matter whether it's Anthropic, ChatGPT, Mistral, whatever. Olama. You can talk to LLMs in a consistent way with a nice API, and you can get tools to empower those LLMs, and typically those tools will come from MCP. However, there's another level above this, which is becoming increasingly noticeable in the world of Python. And that is agent frameworks. Things like Crew AI is one of the most popular in Python. Also, there's LangGraph, which sits above the Python LangChain. So what these do essentially is add an orchestration layer. So you can model things instead of one interaction with a God LLM that you give a bunch of tools. You can architect things as a flow of steps that are orchestrated by the framework, where many of those steps are likely to do a prompted interaction with an LLM, but they'll be more focused and they'll have fewer tools. So that, I believe, is absolutely essential to building realistic and safe business applications, especially in enterprise. So
there's like an element of encapsulation in there where the like God agent or whatever, you generally have to keep a lot in context. You like memory, and like a very wide memory is essential because you have that one God that's got to kind of know everything. And what you're saying is, instead, let's encapsulate smaller bits of functionality into an agent that has its own memory, has its own context, has its own tools.
Are they specializing as well? In other words, would there be an agent that, say, knew Python very well and another one that used...
Yep.
So, okay. That
absolutely.
Specialization and encapsulation.
And that would be more, I would assume that would take less energy. If you were saying, oh, you have a question about this programming language, we'll just go here. And now you don't have to know the world. You just have to know that.
But then the problem becomes on the orchestration, because how do you then have an entry point into your world of agents that knows which agent to call when and for what purpose?
Right.
Okay. So far I've described the benefits of any agent framework, which I think that, this parceling things up into more focused operations. As Bruce said, this does give you the ability to choose LLMs for particular strengths. So, for example, there might be some things that you could do in a business process where, like summarization or whatever, where you could use a local model. Data never goes outside your firewall. So, there are certain things that you could now do in a safer and also greener way. So, however, the question that you asked, James, is very important. So how do you do this orchestration? Okay, the most obvious way to do it is to specify operations that must occur in a particular order, or alternatively wire up a state machine. I mean, that was the first, that's what LangGraph did. It's the first way I tried to do this. Obvious.
So either like a static workflow that's defined by the developer, or the alternative would be, I don't know, like your God, back to your like God agent that knows how to make all the decisions for you, and then has a state machine that knows how to then move between the different states.
Yes, so you can either just have no planning step and have the developer specify what order things should execute in. Tends to be inflexible, tends to be expensive to change, and also you are arguably sacrificing a little bit too much autonomy. The second approach, so what if you introduce a planning system? So one of the ways that you can introduce a planning system, and Microsoft's semantic kernel does this, is you ask an LLM to make a plan and then you execute that plan. The problem with that is you've made progress in that you've broken things up into these finer grained steps, but you're still very reliant on that first LLM to make a plan. And, one of the core problems of anything to do with these models is we have no idea why they did anything, right? Like there's probably somewhere between 300 billion and a trillion parameters in there. Some combination of those parameters said this was the correct plan. It's not like we really know. So Embabel takes what I think is quite an interesting middle approach here, which I believe is novel, which is that it has a planning step, but the planning step is done using a non-LLM AI algorithm, which is deterministic. So basically it knows about goals and it knows about actions that you could chain together to reach those goals. Goals have preconditions. Actions have preconditions and expected post-conditions. So it can use a pathfinding algorithm to navigate a path from the present world state to the desired world state of the appropriate goal. This is interesting because it enables it to maintain a degree of autonomy. So it can choose a different path based on present conditions. It can try to find the cheapest path at any point in time. And it's much more flexible than, say, a state machine, because if there are multiple valid ways, it's not locked into a particular flow, right? It can adapt by replanning after every step. So that's probably of the things which I believe are innovative in Babel. The two biggest things are this planning concept, and secondly, the fact that Embabel is very, very much about a domain model and typing. So Embabel is based on using types everywhere. So there is literally not a single string map key that you can easily get wrong. Like if you look at it, pretty much every example of most of the Python frameworks, although Python's type system has a lot of good things about it, most of these frameworks, when you look at it, it's basically largely strings. There'll be some pydantic models, but once you get seriously into any flow, you are just relying that the string you typed here is the key that you had somewhere back there.
And there's some brittleness to doing the stringly typed, planning of a agent orchestration, because you change one string or the model changes in some way, and now your plan could deviate very significantly.
So did you just use the phrase stringly typed?
That's a normal phrase, right?
Is it?
Yeah.
I've not heard that phrase. That's awesome. I have to use it.
Oh no, it's a great, and what's shocking is how much it happens.
Yeah.
I mean, in regular programming, not with LLMs. It's like people just maps. 99% of the maps in Java are string to string.
Yep. Yeah. So basically, in Babel, there are 0 important map keys. It's like everything is done in terms of the flow of domain objects. Domain objects also are not there just to give you typing. They are there to provide behavior, because this is object-oriented programming. So, so I guess the beyond the planning element, one of the key concepts in Embabel is we should apply OOP to this problem. And strong typing, toolability, testability, all of those engineering benefits that we're familiar with in building complex applications. Thirdly, Embabel is built on the JVM. It's written in Kotlin, but it aims to be entirely idiomatic to use from both Kotlin and Java. And it builds on top of Spring and Spring AI. So this means that if you are using Java with Spring, as the vast majority of the enterprise is, it is pretty much as easy to add an agent flow on top of your application as it is to add a REST interface with Spring MVC. Like, the concepts are native, same best practices, same overall approach to testing. So essentially, Embabel, I think, is the first agent framework that not only brings this higher level approach to deterministic planning, but is really laser focused on how do you bring domain modeling to this area.
Maybe run us through your travel planning example and how some of this would look with types in the travel planner agent.
Yeah, so this is, if you go to the Embabel organization on GitHub, this is the Tripper repo, Tripper. And so it's actually got a web interface. You can run it up and test it. So what it does is actually something that there's some examples of in Crew AI in Python of creating a travel plan. So you start off with, these are the dates I want to travel. These are the people who are traveling. This is the kind of thing we want to see. Then the LLM creates a plan and uses, for example, mapping tools in order to get that plan. In the case of Crew AI, it's using, I think, mapping tools and web research because MCP tools to search the internet are very important. However, it's just all about text in and out. So it's all stringly typed. The difference, as expected from what I explained, with Embabel is our travel planner is entirely based around types. So when you get a travel plan at the end, you get a plan that includes, for example, a list of day objects saying where you will be that day with the date. You get a list of stay objects because obviously you might stay more than one day in a particular location with the location and the date. When it puts that together, for example, to create a Google Map link, it does it in code. It just puts together those locations. So that for example, when I switched to doing that from asking the LLM to generate a Google Map URL, reliability on that went from maybe 60% to like 95%.
So wait, you said it's all strings, but then you're saying it's returning objects. So what do those objects look like?
Okay, the Crew AI one is all strings. The Embabel one is all objects. Obviously, some of those objects have string. So. Yep. So at the end of the day, you get a travel plan object. A travel plan object has a text description of what you'll do, but it also has, for example, a list of web links for useful background reading. It has a list of image links to look at to help make your decision. It has a list of day objects saying where you'll be each day. It has a list of stay objects saying where you will, the different places you'll be staying.
So this is like JSON or something?
No, this obviously can be
Java
rendered as
Kotlin.
JSON.
Java. I see. So it's native Java or Kotlin objects.
Yes.
Okay.
Yes.
Yeah. Okay.
Yeah, and I believe tying into the language type system is really important. With Embabel, we really will eventually port it to other platforms, even TypeScript. I think we'll definitely tie into the language type system rather than just purely rely on JSON. So the advantage of this is that now you've obviously got toolability. Everything that you're building in your prompts is based on the previous domain objects you already have in scope. So, for example, we start off with a travel brief object, which could be inferred by user input. But that's got like start, departure date, return date, and the description of where you want to go, and also information about the traveler. So it's already got some structure. And we use that to build prompts as we go through. We use the domain objects we've already created to base the prompts to our LLM. So now, for example, every single prompt is totally strongly typed, how you build it. You're not going to have keys that didn't end up being in that map. You can also unit test the prompts and make assertions about the hyperparameters and what is in that string. The return from the LLM is also strongly typed, and this is done. All LLMs now support structured return. As far as they're concerned, they typically do speak JSON. So under the covers, Spring AI is generating a JSON schema for the JVM types that we want returned, and that's what Claude or and the other models will see. But as far as the programmer is concerned in Embabel land, they are working purely with domain objects that have no differences from their normal domain objects. The only thing that is any difference at all is occasionally you might want to put a @JSON property description on something because that will actually go into the JSON schema, but it's typically not necessary. So they don't have to extend any magic superclass or extend any interface or whatever. They're pure domain objects.
And so one of the advantages of this approach is that when you enter an agent through whatever, REST API or whatever, however you get to the agent, the planner then can look at the agents that it has available to it and can look at the type information associated with each of those and figure out the path to get to the goal. And so you can do that planning step based on types and then based on the descriptions of each agent and what it can do. But all that information then gets run not through the AI, through the LM to actually come up with the plan, right? It uses your GOP planner.
Yes.
And so the planner is, you said it produces deterministic results. So if I put in a plan, I'm going to get the same every time. But is that an LLM or how does that work?
That is not an LLM. So the first step the planning step is firstly assessing the present world state and the world state that's desired by the current goal. There's also can be optional choice of goal, but let's just think about planning at first. So you see that there's a difference between world state. You have available to you a number of actions. Actions have preconditions and they have expected postconditions.
And those are expressed in types. Both of those.
They are expressed in basically in strings. They're a map of string to string, or actually they're a map of string keys to true, false, or unknown. But this is like lower level infrastructure code. The way the keys is populated is handled by Embabel, and typically it's from the domain object data flow. So, for example, you might have an action that's expressed in Kotlin or Java as a method that takes travel plan request. It will export that as an action that has a precondition of an instance of that fully qualified class name. If that returns a travel plan, that will be exported as a post condition or expected effect that it will give you an object of type travel plan. So this enables world state to be assessed at any point in time, and it enables pathfinding where you're creating a path between these conditions. So it means that if you have the same world state and the same goal, every time you plan, you will get the same path. The planning is pluggable, but the algorithm we're using is something called GOP, Goal-Oriented Action Planning. GOP is practically unknown in enterprise, but it came out of the gaming community. It's one of the most
When
popular.
you say gaming, you don't mean game theory. You mean video game.
I mean video gaming. Yeah,
Okay.
It's probably one of the two main algorithms for controlling non-player characters. So, although hardly any enterprise developer has heard of GOP, I would say the great majority of enterprise developers have been killed by GOP AIs. So this works very well in gaming, this notion of world state. So it's actually a very, very old concept. When I started reading, I was looking for, having concluded probably about 18 months ago when I first started working on this area, that state machines, I didn't think cut it. For sophisticated flows, I was looking for different algorithms and somehow ended up looking at gaming. But this really reminded me of, in computer science in an AI module, hearing about, I think, what was called general problem solver, which is an incredibly old algorithm. There's also PDDL strips. There's been a bunch of these kind of path-oriented AI things that have been around for actually pretty close to 70 years now. So it immediately made sense to me that this could be a way to have the system be able to solve problems in a way that wasn't explicitly programmed, but to solve the same problem the same way every time, and also explain absolutely why that plan was chosen.
And so an example of this in the trip planner one would be a request comes into the outer agent, and with a prompt, the user has asked it to do something, and then maybe the planner decides, okay, I need to turn that into a would you call it the trip planner request or something like that. And so that populates that domain object, but then the plan figures out, like, okay, how do I get from the request to the actual like planned trip domain object? And there's a bunch of intermediary steps that are needed there. And based on the world state of the prompt, it can then walk through that entire, well, it can come up with its initial plan, walk through that plan, but then at each step, it then can evaluate how it's doing at actually working through its initial plan, and then adjust the plan as necessary, because the world state changes after each step that's performed in this agent flow, right?
Correct. Yes. So in the happy path, which I guess is appropriate given this podcast, in the happy path, it will create a plan at the beginning, and as it executes each step, each action, it then reassesses world state, finds that this action did exactly what it said it would do, and just move on to the next action. But there certainly can be cases where it kind of reroutes because something didn't work right. Obviously, there's a whole bunch of retry as well, but where it can actually, genuinely replan. So for the
an example
planner,
of that would be like a human in the loop interaction where you make a call to an agent, and it's like, I really need to know like what your food preference is before I can proceed to the next step. That would then change the world state to then say like, okay, world state, I now need some additional information to continue progressing through the plan. And then you'd have to have some way for the user to fill in that additional information that's needed, but then it could go back and replan and based on the changed world state, and then try to continue through the rest of the plan.
Correct. So let's go back to the travel plan example. It starts off by assessing the input to get a travel brief object. So this is, when do you want to leave? When do you want to return? Who's traveling? And what's your general preferences?
Now, who's doing this? Is the planner doing this?
So there's two ways of doing this. Presently in the Tripper, there's a web interface. So the travel plan or travel brief, I think it is, object comes in populated by a form. So that's just a JVM object.
And that information, it can also, does that information then go to the planner?
That information is the fact that information exists, that an instance of that object exists, enables the planner to say, oh, okay, if I've got something that can act on just that instance, I can invoke that action. So the planner can say, yes, I've got a travel brief available to me. Let's see if there are any actions that could start the flow that take that. So the next step is it will take that and use a very good LLM to say, given that we're starting here and ending there over these dates, I'm going to give you Google Maps tools. I'm going to give you some web search tools. Suggest locations on the way that would be interesting stopping points. So it now comes back with a list of places to research. Then it goes off in parallel in the next action, which fires when it's got the list of places to research, as well as the original travel brief. It fires a bunch of cheaper LLMs in parallel to say, take this place. I'm going to give you Google. I'm not going to give you mapping tools. I'm going to give you web tools. I'm going to give you image search tools. Research this place and come back. So,
but the planner has to understand what a travel itinerary object is, right?
no, the planner doesn't actually have to understand the implementations of the objects at all. If you wanted to, you can surface custom conditions where you write code and it exports a named condition, but typically you don't need to do that. So all the planner cares about in practice is typically the domain, the data flow between these methods on a POCHO. Or whatever the Kotlin equivalent of a POCHO is. So, for example, we started off with the, I mentioned proposed stopping points is a method that takes nothing but a travel brief, and it returns proposed stopping points. So there is another method that takes proposed stopping briefs, proposed stopping points, and a travel brief object, and then does all this research for each stopping point in parallel. So the planner just organizes the flow essentially of action invocations around the types that must be present.
So it's figuring out based on types and the continually updating world state how to progress through to the end goal. And so an agent always has one end goal that it's trying to achieve, or could it have multiple, or could it not have a goal? Or
strictly speaking, an agent process always has exactly one end goal, but an agent could have more than one goal. I think there's more that we can experiment with in terms of goal composition, goal algebra. So, for example, you can add an additional goal to an agent. But typically it's working towards a single goal. So let's go back to the travel planning example. So once we've done the research, we have now these, for each proposed stopping point, we've got a bunch of links, image searches that were actually provided by a pretty cheap LLM. So that kind of low-level research that didn't require thinking, didn't require fantastic LLM. Now we go through each of those places and use a good LLM to say, okay, now we know a bunch of things. Let's choose where we're going to stay. Now, because we're not dealing just with strings, we have a proposed travel plan object that has a list of day objects and a list of stay objects. In the next step, we use the Airbnb API for each of those stay objects. So the fact that we're getting rich domain objects coming back gives us the ability to, execute code. And often, if you can move something from relying on an LLM to executing code, it's going to be a lot cheaper, it's going to be easier to test, and it's going to be deterministic. Well, as deterministic as code is. It's going to be a hell of a lot closer to 100% deterministic than anything you can possibly do with an LLM is. So
increasing those number of 9's is what we're after.
Yeah.
But the planner, okay, so somehow, how much does the planner have to be customized, or is it a completely general thing? It's a general thing.
It's a general thing. In fact, the planner,
How does it know how to connect it's getting some objects in, and then it goes, oh, this object, probably this LLM will be good with this object. How does it know that?
No, that's not what the planner does. The planner is given a goal and the preconditions of that goal and a set of actions. And each action has preconditions and expected postconditions. So all the planner does is create a path from the present world state to the goals required world state through suggesting a list of actions. It doesn't know anything about what those actions are. It doesn't even know anything about LLMs or the domain model. So the way this links to the domain object flow is the planner plans on a world state that has string keys and a value of true, false, or unknown for that condition. The String keys here are way lower level than user code, so they are populated by the presence or absence of particular domain objects. So, for example, it will look at all the domain objects that exist in the travel planner and say one of them is travel brief. So it will create a world state key, it colon, and then the fully qualified name of travel brief. And so that's what the planner says. The planner has no idea what that is. It's, as far as it's concerned, it's just a string. It just needs to know whether it's true, false, or unknown. So the planning is completely distinct of any use of LLM. In fact, the planner tests are just nothing to do with
Unit
LLMs.
tests.
Yeah.
So in that scenario, you would have an action that would know how to take a user input and turn it using an LLM into your domain object, so that then you can get back into the world state with your filled in trip brief.
Yep. Yes, correct. And very often in the start of the flow, you'll have action methods that take a single parameter, like in this case, travel brief, and have a single return type. Later on in flows, you can often get action methods that require multiple different domain objects to have been present. And the planner can work out the correct order to invoke them in. And the planner can cope with the fact that there may be alternative paths based on, for example, when you're creating a domain object with an LLM, Embabel gives you the option of having create object if possible. So, for example, there may be an LLM may be able to process user input and see, okay, I can get a travel brief. I've got the start date, the return date. But with create object if possible, you can say, if you are missing anything at all, don't make it up. Return a different structure to say that it's impossible. And then, of course, the planner will say, okay, I can't get that object. So how do is there another way
Is
that
there
I can do
another
it?
path to get there?
Yeah.
And if there's not, then the planner can go into a state of stuck, right? And so it can say like I there's no way to get from A to Z. And
is this a graph theory thing?
I wouldn't, like, I guess you could think of it that way. I think it's more like if you look at AI theory, things like strips, PDDL, something planning, something definition language. There's been a bunch of these pathfinding things that have been around. Like, for example, strips, I think, was used in the early 70s to try to control simple robots. So basically, it's planning based on preconditions and expected postconditions and creating a path of actions.
So, and then back to Bruce's earlier question, each action can use the default LLM if it wants to, or it could use a specific LLM on the action. So maybe you want to tune a specific action to use a local model or some very highly tuned model to a specific domain. And so each action can choose which LLM it wants to use at each of those steps. And so you're not locked into this like monolithic, everything goes through one model. You can, at each step, have a different model.
Yep, absolutely. So the action, once we've chained together actions are typically methods on your agent class, right? And they just take domain objects. There's nothing magical about the domain objects. So an action could, of course, just do something like make a REST API call. It could look up a database, right? Like, actions could also achieve their goals through code, and many do. But the most interesting case and the sexiest case, of course, is the LLM case, where we invoke the LLM. And Embabel gives you, very, very easy to use primitives for doing this. So create object if possible, and generate text. And when you call these, you use what's called a prompt runner, and that enables you to specify the LLM you want, specify the hyperparameters like temperature, max tokens, all those kind of things, and also provide the tools like MCP or other tools that should be available to that LLM.
And then there's two other elements of the action that I think are unique, or at least from what I've seen, which is the cost piece, managing cost, and then the second one is the knowledge cutoff. So maybe explain those pieces.
Okay, so you're going to be executing all your LLM interactions through these, three methods. This means, of course, from the framework perspective, everything is instrumented. So, like, it emits events for anything you can possibly think of. And at the end of the day, after all of your process is concluded, it can look at all the LLMs that were invoked. And if it has pricing information for the LLMs, it can use that to put together the total cost of this, which I think is very important. This also enables agent processes to be cost aware. So it can also expose the cost. So, for example, you can set a budget for a process and it can start putting the cost in a prompt and saying, by the way, you were supposed to spend at most 80 cents on this. You're already up to 66. So you might want to think about slowing down token usage. So with respect to, James, you mentioned knowledge cutoff date. To do really useful things with LLMs, we need information about the LLM. If you go to Claude or ChatGPT and you say, for example, tell me about the recent Australian election, the knowledge cutoff date of the model is probably last year, but that knowledge cutoff is in the system prompt along with a lot of other stuff. So it will correctly realize that the only election it knows about in general knowledge was 2022. So this isn't the one you mean. And it will try to do web research. When I first was calling these models through the APIs without providing knowledge cutoff date, if you ask for the recent Australian election, it might well say 2022 because, seems reasonably recent given the cutoff date. So if you want models to use tools correctly, particularly search tools, web search tools, you need to provide the model with its own cutoff date, knowledge cutoff date, because it doesn't know. You also obviously need to provide the current date because it doesn't know that either. So Embabel is a higher level framework than something like Spring AI. It puts these things in automatically. So, for example, if it knows about the LLM, if it has knowledge of the LLM's knowledge cutoff date, it will put that in every prompt.
That may impact tool selection from what you're saying. So by having that knowledge in your prompt that you're sending to the LLM may make a different decision around whether or not to call tools to get the information that it needs. So if you're asking about the 2022 election, it doesn't need to make a tool call. But if you're asking about the 2025 election, then it's going to be like, I need to call a tool to get that information.
Yeah. So, for example, if it were unable to use tools, I think both the present Anthropic and OpenAI models that we use, most of the ones we're using, probably are pre-November's election. So if you just asked about the presidential election and didn't provide knowledge of the present date, they'd probably happily give you 2020. So that kind of thing is very, very important. And it is, an illustration of the way in which Embabel tries to be a higher level framework, right? I don't think developers should have to think about that. That you should be able to make a call with the assumption that the LLM is going to have information that it always needs without you specifically providing it.
And then on the tool selection piece, you have done something around creating tool groupings or tool roles, which allow a specific action to only have a group of tools that it has access to. So it's pretty easy to have granular control around, okay, this action has these tools, this action has these other tools, and you don't have to, it's pretty easy to adjust the individual actions to have only the tools that you think it may need to achieve that action.
Yes, I think that's very important because once you've made this kind of factoring of longer term flow into individual actions, many of which are prompting an LLM, your prompts become much shorter, more focused, and also the tools can be localized as you're describing. This is really important for a number of reasons. So sometimes it's helpful to think about LLMs the same way we think about ourselves. Let's suppose you walk into your kitchen and you are told to clean this kitchen, there are 200 tools available to you in the house and the shed. Choose the right tools and clean the kitchen. You're going to waste a lot of time doing that. Whereas if you're told you have a mop and a cloth and a cleaning bottle, but some cleaning liquid, now clean the kitchen, that's much easier, right? So, I think you are confusing models unnecessarily where you have a large universe or really large universe of tools. And you are also wasting tokens because, you've got to pass up with every invocation the tools that are available to the model. And it's quite a lot of tokens.
The descriptions and the schema information.
Exactly. Like every single tool, you pass up 200 tools, you're using a lot of tokens. So if you design your app in a way that you could have an action which knows that there are literally only 5 or 10 tools that could be relevant here and you pass them, you're making life easier for your LLM, you're potentially using a cheaper LLM, and you're saving a lot of tokens. So obviously you can, other agent frameworks enable you to localize tool calls, like for example in Crew AI you can do the same thing. There is, however, 2 ways in which Embabel innovates in this respect. The first is that you can expose tools from your domain objects. So remember how we've got these domain objects that flow through? If you are creating a prompt and one of these domain objects is, or one or more of the domain objects is in scope of that method,
because it was an input parameter.
Yep. Any annotated at tool methods on those instances will be exposed to the LLM. And so that is actually really quite interesting, where you can have the safe behavior of your objects exposed as tools to the LLM. But obviously, very often you want to use LLM tools for the wider world, and these typically come from MCP. So we don't say, for example, here's the Brave web search tool, here's the Brave image search tool, here's the DuckDuckGo one. What we say is, okay, you can request the web tool group. So your code, there's a level of abstraction between what your code asks for and what the platform provides. This makes things a lot easier to test because now you can easily make assertions that your code asks for the correct tools. But it means that in different environments or for different users with different privileges, you can potentially resolve those tool groups. The platform can resolve it differently. So I think it's just good engineering practice to have that level of abstraction that enables more choice at runtime.
And then there's probably some safeguards that you could build on top of some MCP stuff there. So MCP, I think, recently added some additional metadata to tools around, like, is this a destructive action? Is this a mutating action? And so you may be able to say, like, okay, for this tool group that I'm going to expose, I don't want any write or destructive actions available in this particular one. Maybe later in some other action you do want to do some mutating action, but for this one, no. And so you could key off of that metadata that's exposed through MCP tools to put some more granular control around what that tool should be able to do.
Absolutely. So, for example, the coding agent uses file tools, which are written in Kotlin, because there's no reason to use MCP when you can just do it in the platform. And file tools are intentionally broken up into read tools and write tools. So if an action doesn't need to make changes, like, for example, if you ask it to explain this code, it doesn't get access to tools that enable it to make any changes. So I believe firmly that absolutely localizing the tools that you expose is really important to getting more deterministic outcomes, saving tokens, and enhancing testability.
You also were going to talk about Kotlin, your experience with Kotlin.
Oh, yeah. So you've been building Embabel in Kotlin, even though Java developers can certainly use it and have a great experience. What was the reason for doing Kotlin? And as part of that, tell us about your KotlinConf presentation and how you built it.
Yeah, okay. So, well, I started off looking at this space. I was working in Python. And yes, I was very pleased with the fact that by the time I was doing Python daily, type-ins were getting pretty good. So, yeah, I mean, 10 years ago, I would have loathed that. But I relatively quickly came to a couple of conclusions. One is that I don't think Python is a great language for building large-scale applications. And I think if you look at the enterprise today, there's an awful lot more Java in critical systems than there is Python, and I think there are good reasons for that. So I also noticed that although there's a lot of Gen AI activity in Python, it's not really as bound to the language as, say, the world of lower level machine learning is. So, where you've got TensorFlow and PyTorch, you've got all this amazing stuff that if you're doing lower level machine learning, it's pretty damn hard to argue you should do it in any language other than Python. But that's not the case with Gen AI. I mean, these models are a pretty simple HTTP call away. So I switched to Java. And at this point in time, I'd not written probably more than 100 lines of Java in the last 10 years. So I'd actually never written a line of code that uses records, enhanced switch statement. So, I actually found that Java was significantly better. And going back to using Spring was just amazing. And, you could argue I'm biased. I think I've spent probably 15 years where I didn't use Spring. And to some degree, it's like a breath of fresh air when you go back and think, yes, these problems that we solved in 2003, people are still solving themselves badly in Python. There are just many things that it does that are really elegant. So I found my productivity actually went up when I switched to using Java, Spring, and an early version of Spring AI, even though at that time I was rusty in Java and highly fluent in Python. And what made me switch to Kotlin was actually when they took the string template preview out of Java, and I had to change 300 instances in my code. And it just made me very annoyed because, coming from Python with F strings or TypeScript with backtick strings, it's just embarrassing, right, that we don't have that in Java. The other thing that is still really annoys me in Java is collections and lifting to streams. I mean, it makes every single thing you do with a collection, which is a lot of things you do, makes it just have this ceremony that makes it really hard to read, to the point where, quite honestly, very often you look at it and think, why isn't this a for loop? It'd probably be easier to understand. So it was those two things that caused me to look at Kotlin. And I pretty quickly fell in love with Kotlin. Firstly, Kotlin has a very gentle learning curve. I mean, obviously, I've done quite a bit of Scala, say 10 years ago. So, obviously, I had certain advantages versus someone who'd worked only in Java. But nevertheless, the learning curve is very gentle. And unlike learning Scala, if you're on the JVM, you don't have to lose the things you're used to. Like Scala always had the sense to me that it was at war with the JVM. And many people in the Scala community were literally at war with every single piece of every single Java library. Whereas Kotlin is not like that, right? For example, if you look at Spring, the Spring team has embraced Kotlin. JetBrains have embraced Spring. Everyone gets along really happily. Obviously, a very large proportion of the Kotlin community want to use Spring. A significant proportion of the Spring community want to use Kotlin. It's great. You don't have the pain with collections. So, obviously, Scala had an infinitely better collection library than Java, but you had to marshal between Java and Scala collections at every interop point, and it was really painful. Yeah. In Kotlin, it's not like that. You write your collection handling code in Kotlin, and Java code can just work with it seamlessly. So I like the fact that nullability is handled much better. Also, obviously now Java enables you to annotate things. So if you look at the core Spring framework, they have annotation, nullability annotations. Yeah. So the interop story is really great. I just find that I have more fun if I program in Kotlin versus Java, and I believe I'm more productive.
Yeah.
Having said that, we are absolutely committed to making Embabel look perfect from Java. So we don't want Java developers seeing a .companion. We don't want Java developers seeing import something KT. That's not idiomatic. We aim, and I think we have achieved it so far, for it to be 100% like this was a framework written in Java.
Nice. Yeah, I think Kotlin really is a better Java, whereas Scala I think maybe at one point tried to be a better Java and then became a whole different thing. And so that created, like you're saying, kind of a friction between Scala and the world of JVM and JVM libraries. And so whereas Kotlin, I think, really is better Java and fits nicely with that ecosystem and doesn't bite it.
Yeah.
Well, I think with Scala, essentially, I think we've typically thought about Scala wrong. Like at this point, we'd probably think of Scala as a failed enterprise language. Actually, that's not what Scala is at all. Scala is one of the most successful academic languages. And if you look at Kotlin, we wouldn't have Kotlin without Scala. So, I think that some of the things that caused Scala to be pretty damn scary in real usage were things that make total sense if you look at where Martin was coming from. And I mean, I think Martin markedly advanced the industry with Scala.
Yes.
Absolutely.
Yes.
Yeah. Well, and having many PhDs researching these like small portions of the language for years and writing doctoral theses, or I don't know what's the plural of thesis, theses around these like very small parts of the language, like benefited a lot of people because he was essentially becoming this research arm for programming languages that then Python and Kotlin and the other languages benefited from.
Yeah, I have tremendous respect for Martin. And I think another problem with Scala was the community. We just had this uneasy, for example, there were a lot of Haskell people who knew they couldn't get jobs writing Haskell, so they preferred to write Scala that nobody could understand. And I think that was a real factor. There was also in the community, certainly not in Martin, who's an absolutely lovely guy, but there were a lot of people in the Scala community who were really conceited and basically felt that they were infinitely smarter than anybody else. And the fact that nobody could understand their code just proved how smart they were. And obviously, as we know, if no one can understand your code, that proves you're a truly terrible developer. But that was not the metric that was widely used in the Scala community. And Kotlin's very different. Kotlin is like a practitioner driven language, and it really shows. It's about doing things that often are a bit more pragmatic than the Scala approach, possibly less clean in some ways, intellectually, but that actually make common things easy to do and make the code pretty readable.
I think the nullability is a good example of that. Like in Kotlin, I would love to have question mark generalized to something beyond nullability, but like pragmatically, the place where you use that most is around nullability. And so the fact that Kotlin only uses question mark on nullable chaining kind of makes sense. But then the Scala part of me is like, man, I would sure love to have type classes generalize this question mark into anything monadic that has a, what would that be? I don't know if it's, I don't know if it'd be monadic or something, but anyways, like some operation, to chain those things. Probably monadic, but yeah. So I think they certainly make some trade-offs in Kotlin for the pragmatic path and not for the more power user.
It has such a different feel to me. Kotlin does. It does. It feels like the people they were thinking. They were solving a different problem. Yeah, I think it's basically what you said. Martin was doing language research and did wonderful, valuable things there. But for the vast majority of people, they needed somebody who was thinking about how do we make this these more advanced features accessible to you so that you don't have to struggle with them. We're not going to assume that you're only going to program in Kotlin. We're going to assume that you're going to try and use lots and lots of stuff that's already been written for the JVM.
Yeah.
And it has that different feel to it.
Yeah.
No,
and I think there is also a friendliness towards incremental learning. Like I think the Scala community, and again, Martin's a lovely guy, but there were people in the Scala community who were anything but welcoming. So somebody came into that community who wanted to use Java libraries and initially wrote Scala that looked quite like Java. Instead of being welcomed, they would be scorned and, they're made to feel bad. Kotlin's not like that. It's possible to gradually understand more idiomatic things about Kotlin and start using them without people telling you that you're stupid in the learning process. And I think that's really important. I think with languages, the nature of the community, as with open source projects or anything, the nature of the community has so much effect. And it is driven by modeling of early adopters. Unfortunately, in the Scala case, it wasn't predominantly Martin. It was some of the other early adopters who absolutely hated object-oriented programming. And, I think they set the tenor of that community.
Yeah, I don't think Martin felt like that was the problem. He wasn't trying to solve the community problem, whereas Guido, that was super important to him. And I know that people tried to see if they could steer the Scala community more towards the way Python worked, but as you observed, it has to be built in from the beginning, because once the I guess really smart people get in control of things, then you can't get it back from them. I don't know.
Well, I think the problem is partly that functional programming brings out the worst side of some very smart people. Obviously it's beautiful and elegant, but I think that's part of the problem, that people just get obsessed by the fact that it's beautiful and elegant. And I think languages that enable you to be too clever are actually often dangerous. So that was definitely a challenge. And I mean, literally, I think, type systems are a good case in point. I think there is a limit to how much you should be thinking about types. It's clearly well beyond the point where you've dispensed with all the string maps. But on the other hand, you can waste a lot of time trying to express something really elegantly in the Scala type system. And when you've concluded it, it may or not be worthwhile. Like, I actually thought the collections libraries were worthwhile. I mean, they were beautiful to use. If you opened any single source file, your head exploded. But, that was probably a reasonable trade-off, that we're going to create this thing that's really beautiful to use. If you're looking at typical application code, that's totally the wrong trade-off, because you cannot afford to have people's head explode when they open source files.
Yeah. Yeah. Well, thank you, Rod. Is there anything we missed on Embabel?
So Embabel is open source. The community is growing pretty rapidly. We've got a community Discord, so definitely welcome contributions, issues, pull requests, people to join the community. It's really, really growing very quickly. So yeah, it's a great ride. It feels for me like, in terms of my personal experience, this is equivalent to maybe May 2003 with Spring. And it kind of feels really good. You get, I guess I haven't done that much outward facing open source for a few years. And it's pretty awesome. I mean, the fact that you get contributions from around the world, that, I guess it is easy to forget that open source is this truly amazing thing that enables people to bring their smarts from wherever they may be in the world.
Yeah. And you've had a series of blog posts about Embabel over the last few months and really enjoyed reading those. Where can people find those at?
So I post on Medium. So if you look for Rod Johnson on Medium, I also am on Twitter and LinkedIn. So if you go to Twitter, Springrod. So I'm pretty active in terms of trying to get the message out. Nice. So yeah, the aim here is that we want to make it easy for the enterprise to get from where they are, which is predominantly the JVM, to reaping the potential benefits of Gen AI. But beyond that, we want to demonstrate that the model that we've got with the planning element, the emphasis on a rich domain model, is the best model. I truly believe it is far in advance of anything that's out there, including the Python frameworks that are very popular. So we actually also want to build the best agent framework.
Nice. Awesome. Well, look forward to diving in further, and I appreciate all your work on this. I think it's been fun for me to learn, and look forward to diving in further.
Thank you.
All right.